Hi folks, this is Richard here, and this is the night sky that we'll be looking at tonight. Okay, so always like to start off by thanking Dan Bowden, who's a keen supporter of all the things that we do out here, particularly the night sky program and so on. Anyway, here we are well into spring now, so we're going to be having a look at what's in the sky right now. Now, starting off, I guess nobody can miss it. If you go out any evening that's nice and clear, there's this big bright star that you can see out there. In fact, you can see it long before it's dark. Well, of course, it's actually no star at all. It looks like a star. It's in fact the planet Venus that's shining out there, what we call the evening star. So there, for those of you watching it on TV, you can now see where Venus actually is. And we only ever see it in the morning, when we call it a morning star, or the evening sky just before after sunset, when we call it the evening star. And that's because Venus is closer to the Earth, closer to the sun than the Earth. Right, so that's the only times we can actually see it. However, even with a small telescope, if you have a glance up into the sky and look at Venus, you'll see that it shows phases just like the moon. Now, again, this is because it's closer to the sun than the Earth. So a lot of the time we just see the dark sky. So at the moment, it looks essentially like a half moon. All right, so let's say the planet Venus, and of course of all the planets, it's the one that's most closely resembles the Earth in physical size, although conditions on the surface are far different. Although on the other hand, there's a lot of evidence that once upon a time it was maybe have had thousands and millions of years ago conditions similar to that of the Earth. Okay, so that's Venus. Now, as it gets dark, looking up there, we've got Venus will still be in the sky, because at this moment, it's looking from where the Earth is, it's maximum angle that it can be from the sun. So it's setting quite late. But looking up there in the evening sky, there's various things that you can find your way. First of all, looking out there is what we call the Great Square. And that's almost absolutely due north. It's a good sign for that. Not particularly reasonably bright stars, but it's dead easy to pick up because it's well away from the Milky Way. So that's the Great Square there. Now, in addition to Venus, there's actually some other planets in the sky at the moment. Right? So there's Venus, right? And the second brightest star, in fact, again, you'll be able to see that in the twilight, is the planet Jupiter, which of course is the largest planet in the solar system. Right? And is indeed an absolutely magnificent object to look at in a telescope. You see all these bands; it's continually changing what you can see, but we never see the surface, because Jupiter hasn't got a surface like the Earth has. In fact, Jupiter is far more like the Sun than the Earth. You know, Jupiter is bigger than all the other planets in the solar system put together. And as I say, its characteristics are more like the Sun than the Earth. So it's a big ball of hydrogen and of hydrogen gases and so on. So what we ever see is just the uppermost cloud layers. But as we'll be looking at a little later on, it's just like the Sun, it's got its own planetary system. Now, Jupiter is not the only planet out there in our sky at the moment, right? In between Venus and Jupiter, you'll see another brightish star, and that's the planet Saturn. Right? I always like to call it our Lord of the Rings. And you know, folks, Saturn is a little bit smaller. The globe is a little bit smaller than Jupiter, but its composition is very similar. It's what we call a gas giant. It's made mostly of gases and liquids and so on. Right? And again, like Jupiter, it's got its own moons and so on. And of course, what Saturn is most famous for is those wonderful rings. So if you ever have an opportunity of seeing that, even through a relatively small telescope, it's actually quite stunning. When you first look at it, it doesn't look real, because it looks like something out of a picture book when you look at it through a telescope. But in actual fact, it turns out that all the other giant planets, including Jupiter, have also got sets of rings. It's just that they're not as big or as bright as Saturn. And what are the rings themselves? Well, what we think they are is the debris of a couple of moons which have been dragged in too close to Saturn and have ended up being colliding. And what we're looking at is the debris of these moons swept around Saturn. And of course, with the passage of time, those rings will gradually dissipate. Right? So it doesn't mean it won't happen again in the future. Well, they're not the only planets in the sky. Now, for those of you watching on TV, just to the right of the Great Square, I've got an arrows come down pointing at a position of another planet. Now, you're not, unless you're an astronomer, you almost certainly won't be able to pick it out. You can, on a dark night, you can just see this with the unaided eye. It just looks like a faint star. The only thing you will notice, though, is that over the months, its position in the sky slowly changes. What we're looking at here is, in fact, is another giant planet. It's the planet Uranus. And this, as I said, is another one of those giant planets. And it too has rings, and for those of you watching this on TV, you can see a photograph taken it by one of the Voyager spacecraft, and you can see the rings there. Again, we didn't even know it had rings until we actually sent a spacecraft out there. But again, almost like Saturn and Jupiter, it's probably the remains of things that get too close to these giant planets and get smashed to pieces. So there's the there's the big bright planets that we can see in the sky at the moment. And nice thing is, once you've identified the Great Square, you can easily pick up lots and lots of other interesting objects around that part of the sky. The very fact that we're looking at the planets tells you that this must be the zodiac, because you all heard of the signs of the zodiac and so on. Well, the zodiac are the constellations, the patterns of the stars that lay along the plane of the solar system. See, all the planets orbit around the sun in the same direction, right? And consequently, they always appear, the sun, the moon, stars all appear to move through the same constellations. So when we're looking at that panorama there from Venus going through to Uranus, we know that all the background stars there form different constellations of the zodiac. But I doubt unless you're an astronomer, you probably haven't picked them out. All right. Anyway, looking to Jupiter is a large planet. I've just put up the Earth for those who watch it on TV, showing you how Uranus is about 4 times, its diameter is about 4 times that of the Earth. So again, a giant planet. All right. And its distance from us, the reason why it appears to be so small is because its distance from us is virtually 20 times further away from the sun than the Earth. So it's right in what we would call the outer reaches of the solar system. And in fact, it's so far, even travelling at the speed of light, it takes you almost 3 hours to get there. So in other words, when you look at Uranus for a telescope, you're not seeing it as it is then, you're seeing it as it was there nearly 3 hours ago. And it's always one of the disconcerting things about astronomy. As you look out into space, the further you look out, the further backwards in time you see. So we always see the universe not as it is, but as it was in time. Anyway, we'll just bring up those constellations of the zodiac. And for those, again, of you watching this on TV, you'll notice that Venus is actually in the constellation of Sagittarius. You'll see that this is also where Venus is also where the Milky Way is, right? And Sagittarius and Scorpius, which is in front of it, lay across the Milky Way. So they're composed of big, bright stars. So Venus is in Sagittarius. Then coming back, we have Saturn and Jupiter, and they're both in the constellation of Capricorn. Right? One near the front and one near the rear end of it. Okay, so you've got Capricorn. Then following behind Jupiter, we've got the constellation of Aquarius, and then Pisces, and the 2 fish of the Pisces are wrapped around the Great Square. And finally, we come down to Aries the Ram, and that's where Uranus is. So Uranus is in Aries. And incidentally, at the moment, this week, the Earth is at its closest point to Uranus. So that's why I'm actually spending some time picking it out for you at the moment. Right? So those are the constellations of the zodiac you can pick out. Well, interesting thing is that, the Earth has got a single moon, but all of the giant planets are just like miniature solar systems. They've all got their own system of planets or moons around them. And Uranus has actually got 27 moons. So distant that without very big telescopes you can't see them very well here from Earth. And a lot of them have been discovered by spacecraft and so on. So 27 moons orbiting around Uranus. Well, that's nothing compared with our planet Saturn, because Saturn has got 82 moons. Right? It's got more moons actually than Jupiter has. Right? So imagine that if you're on Saturn, you've got 82 moons orbiting around them. And each of these moons is an entirely different type of world. But the most fascinating of them all is, in fact, the world Titan, which even in a small telescope you can see Titan near as it orbits around Saturn. You see it's a faint star, but you'll notice from night to night its position gradually changes. Well, Titan is the biggest moon in the solar system. It's about half the size of the Earth, right? And it's got an atmosphere, but it's also got seas down there and so on that we can see. But don't for a moment think this is a world like the Earth. You're really looking at a bit of science fiction here, because if you land on Titan, which we've actually done with a spacecraft, yes, it's got seas and so on there, but they're not seas of liquid water, they're seas of liquid methane and ammonia. Right? So we've got this weird and wonderful world there where the chemistry of it is entirely different from that of the Earth. But from a distance, it has some properties that look like the Earth. And of course, what we're interested in as far as Titan is concerned is what's down there. Are there living things on the surface of this planet? Something we still don't know at the moment. Anyway, I thought at this point we'll have a little bit of a break. And for those of you who are watching this on TV, you'll see a picture's come up and it's showing Mani and Sol. All right. You see all the names of the week and the planets are all named after ancient gods. And I hate to tell you this, guys, but the supreme god is actually a goddess. It's the sun, and her name was Sol. And that's where the solar system comes from, Sol. And her brother was Mani, and that's where the word moon comes from. Right? So and you can see them both believed to be on these great chariots. So when you see the sun, people believe that was Sol in her chariot driving it across the sky. Right? Anyway, what we've got is a little piece of music for you now by Vanessa May, and we'll come back and have a look at some of the other things up in the night sky in a little bit more detail. Can you hear that okay? It sounds quiet. Hi folks, you're back with Richard and the night sky there. Have listened to a bit of from Vanessa there, wonderful violin work. Jupiter, the other big giant planet in the sky, has got 79 moons. But the interesting thing for the average person, if you've got a small telescope, you can see 4 of those moons with a pair of binoculars. You'll see them as little tiny stars lined up alongside next to Jupiter, and you'll notice them even over a matter of several hours that some of them will change their position as they're orbiting around it. Right? So you've got 79 moons. But as I mentioned earlier, in a sense, the giant planets, Jupiter and Saturn particularly, are more like the Sun and the Earth, and planetary systems appear to be something that forms just around every one large object as it's formed. So in a sense, these planets have got their own solar systems, right? And indeed, they're not just some moons, they've got some wonderful worlds out there. We've just been looking at Titan, which orbits around Saturn, but also Jupiter's got some really interesting worlds. Those 4 big bright ones are called the Galilean moons because they were in fact first discovered by Galileo, and one of the first people to use a telescope. And there's these 4 Galilean moons. Number 1 is, every one of them is absolutely different. Closest of the 4 bright ones is Io. And when we sent spacecraft out there, we made some amazing discoveries because Io is the most volcanically active world in the entire solar system. Anytime we looked at it with a spacecraft, there was never less than 3 volcanoes somewhere on its surface erupting. It was all these beautiful colours of yellows and oranges and reds as the surface of it is covered in sulphurs and so on. So a real chemistry mix, not a place you'd like to live on. It'd be pretty dangerous down there with all this volcanic activity taking place. But it's a spectacular world where its surface is continually being changed. In fact, when we look at the surface, some of you who've got this watching this on TV see this wonderful photograph I've taken of Io. But the entire surface changes in about, not like millions of years for the Earth, but in just 1,000 years. So intense is the volcanic activity. The entire surface is changing in a matter of just 1,000 years. So that's Io, the nearest one. Right? The next one out from there is Europa. And Europa is the dead opposite. Whereas Io was a world of fire, here we've got Europa is a world of ice. But the interesting thing is that when we look at Europa, there's these big cracks on the surface. And what we do know is stuff comes welling up from underneath there, because underneath that ice, it appears, is a worldwide ocean. But this is an ocean of water. So beneath the those ices of Europa is an ocean. And in some degrees, that protects that ocean. That ice protects the ocean from above. Now, what we do notice is that water wells up through these cracks, and for those of you looking at this on TV, you can see that a lot of the cracks have got an orange colour. Indeed, once the cracks have opened up and the water's come up, after a while there is some sediment and that there, and it freezes out. But the interesting thing, the reason why it's got that orange colour is actually organic material. And so what scientists now believe, if we're going to find living things anywhere else in our solar system, Europa is the most likely place. It could well be that colouring that we see, that brown colouring, is coming from living things. I'm not saying it is life at this stage, we don't know, but it's the most likely explanation to what we can actually observe. Right? So that's Europa. Then as we move further outwards, we come to Ganymede, the largest of Jupiter's moons. And I always like to call Ganymede the crystal planet, because this moon is big. I mean, it's as big as the planet Mercury. And what you've got is a surface which is then covered in water, which is then frozen down. But it's so cold on Ganymede that water has the same feel and consistency as glass. So when you look at Ganymede, you look like you're looking at this glass gem with all. You can see all the continents and features underneath it, but it's covered with this wonderful glass film which preserves it. So that's Ganymede that we're looking at there. And finally, of the four big ones, we come out to Callisto. And Callisto is absolutely covered in craters. In fact, and we haven't always got answers for the reason why these different features are there, but what we do know is that Callisto has got more craters on its surface, and these are craters caused by impacts, things smashing into it, than any other place in the solar system. It's absolutely littered with them. And indeed, its surface again is icy. And for those of you watching this on TV, if you look at that big impact crater at the top of here, you can see where something big has smashed into the planet, and you can see these rings around it. Well, those rings are where the ice has shattered. So again, we appear to have water underneath that ice there. So that's the shattering. So that's Callisto. So as you can see, as we're going on, there's more and more weird and wonderful worlds out there amongst the orbiting around in our own solar system, which is essentially right on our doorstep. So that's Callisto looking out there. So now going back to the Great Cloud and looking up at those stars, what I want you to remember is that each of those stars that you can see in the night sky is a distant sun. And just like our sun, they will have planets orbiting around them. That used to be a theory up until quite recently, but we've now got the technology to detect planets around other stars, and even with our limited technology at this stage, we've already discovered over 4,000 worlds around other stars out there. And just bear in mind that in our Milky Way galaxy alone, there's 100,000 million suns. So just imagine how many worlds there are out there. Just about anything we can imagine exists out there somewhere. Now, going back to our Great Square, right? If you look at the Great Square, there's tends to be a line of bright stars going down to the right of the square from the lower right-hand star. And these stars here are actually the brightest stars in the constellation of Andromeda. And unfortunately, this is as high as the lovely Andromeda comes above the horizon here. But of course, the reason why I'm picking it out for you is because here in Andromeda is the most distant thing that can be seen with the unaided eye. For those, there's an arrow coming up showing where it is. It looks like an elliptical, hazy piece of light. You can see this with the unaided eye looking towards the horizon, so long as you've got a dark horizon. Back in Europe, in the northern hemisphere, it comes virtually overhead. And I can remember, when I was a teenager looking at this hazy patch of light. Well, this, of course, is the great galaxy in Andromeda. And it is a gigantic spiral galaxy, about the same size as our galaxy. But its distance is over 2 million light years. So in other words, when we look at this, we're seeing it as it was over 2 million years ago, around about the time our species was coming into existence here on the Earth. So there's this gigantic galaxy out there. And our galaxy, the Milky Way, is part of a cluster of galaxies out there. And Andromeda and the Milky Way are the two biggest out there. So that's Andromeda that we can see out there. Right? And I've pointed out because this is the only time of the year you can actually spot that. Now, if you go along from the Great Square, right, and you head out through Andromeda, and you come to a little cluster of stars, and that's the Pleiades, which we here know as Matariki, right? And of course, it is the most famous star cluster in the world. It is a fascinating thing astronomically. I won't go into all the details now because we've got a special program coming up all about Matariki in the near future. All right. So what we've got is Matariki Work of the Gods, and that's going to be at 7:30 p.m. this coming Saturday, November the 6th at Stonehenge Aotearoa. That's 7:30, Matariki Work of the Gods. And we're going to take you through and show you all the important stars which Matariki is associated with. The waka in the sky, the house in the sky, these can only be seen at a certain time, and so we're going to be taking you through to show you all these things which we can identify. Finally, if you come along to that, the following weekend we've got 2 interesting programs out at Stonehenge. It's the Phoenix Astronomical Society meeting. We've got Life in the Venusian Clouds, because just recently it looks like they've discovered living organisms up there in the Venusian clouds. So Kay Leather's also going to be doing a special presentation there, and I will also be doing one on stellar extremes, looking at all the extreme objects in the galaxy, the biggest, the smallest, the most massive stars of all. Finally, folks, I'll just finish off by saying Stonehenge is open from 10 a.m. to 4 p.m. That's Wednesday through to Sunday. So do come up and see us. And don't forget Matariki this Saturday, right, 7:30. And the following weekend, then we've got the special ones on the stars after that. Catch you next week.
Each week I'll be playing material from established and new artists worldwide. So please join me on